This is a key to the test on solving equations and inequalities. So in problem number one, you want to solve this linear equation. Now, notice that this linear equation has parentheses, has grouping symbols in it, and there's one set of parentheses here, another one here, and another one here. So what you need to do, first of all, is get rid of those parentheses. And so since you notice that this expression that's inside that first parentheses here, which is 7x plus 5, is being multiplied by 3, we're going to multiply each of those terms by the number 3. And so we're going to use the distributive property. So I'm going to use the distributive property here. And on this one, remember you can always think of subtraction as an addition problem. So even though it says subtract 6, I can write this as add a negative 6. So I'm going to distribute a negative 6 in this case. Now you got to be careful on this side. Remember the order of operations says I have to multiply before I add. So don't make the mistake and say 6 plus 4 is 10 and distribute the 10. Because if you notice that this expression here, x plus 5, is only being multiplied by 4, not 10, only being multiplied by 4. So you need to make sure that the only thing you distribute is the positive 4. Okay, so now let's go ahead. Now remember, this is the work I need to see to get all the points. All right, so 3 times 7x is 21x. 3 times 5 is 15. A negative 6 times x is a negative 6x. A negative 6 times a negative 4 is a positive 24. All right, so that's one of the areas where students can sometimes make a mistake. They'll write it as negative 24. And then minus 2x equal, and over here we get 6, and then we're going to distribute the 4. So 4 times x is 4x. So I get 6 plus 4x, and then 4 times 5 is 20, positive 20. Okay, at this point, we're going to go ahead and combine like terms on each side. So notice I have a positive 21x and a negative 6x and a negative 2x. So if you need to use your calculator to combine those three terms, then you need to make sure you do so you don't make an error. So basically, you're going to say this coefficient here is a positive 21. You're going to subtract 6, right? And then you're also going to subtract 2. So minus 2. And so we get 13. All right, so what some of you sometimes do is you'll say 21 minus 6, 21 minus 6 equal, and then you're going to say, well, now I've got to subtract 2. So subtract 2, and notice you still get 13. So when I combine those three terms, I get 13x. All right, so now we're going to combine the constants, and so my constants are positive 15 and a positive 24. So if you need to use your calculator. Positive 15 and a positive 24 is a positive 39. So we get 13x plus 39. So that takes care of combining like terms on the left-hand side. Equal, make sure you put an equal sign. And on the right-hand side, the only two terms I can combine are these constants. So I get 4x, and then 6 plus 20 is 26. All right, so now at this point, remember this is a linear equation. The variables are all being raised to the first power, x to the first, x to the first. And there are no variables in the denominators. All these denominators, you can think of those as being the number 1. Okay, so now let's go ahead and bring the variables to one side, constants to the other. So I'm going to go ahead and bring the variables to the left-hand side. So um, in this case, I'm going to have to subtract 4x. See, if you add 4x, it's not going to help you. 4x plus 4x is 8x. So you want this to be a 0. So I'm going to have to subtract 4x. But what I do to one side, you have to show that on that other side. So that's one of the properties of equality. What operation you do to one side, you do to the other. All right, so now we're going to combine like terms with what I just did. So 13x minus 4x is 9x. So I get 9x plus 39 equal, and then on this side I'm left with 26. And so now I'm going to subtract 39 from both sides, because right now I'm adding 39. The opposite is to subtract 39. And when I combine like terms, I get, this is 0. Those are opposites. Positive 39 and a negative 39 is 0. So I get 9x is equal to 26 and a negative 39, or 26 minus 39. Again, use your calculator if you need to. So 26 minus 39 equals a negative 13. All right, at that point, I've got to get x by itself. So right now, multiplying by 9, the opposite of multiplication is division. So I'm going to divide both sides by 9. And so 9 divided by 9 is 1. 1 times x is x. So I get x equal. And this is reduced. So I get negative 13 ninths. Now, it is a improper fraction. So remember, the numerator is greater than or equal to the denominator. So that's an improper fraction. So I can write this as a mixed number. And so in this case, 9, if you need to do it here, you do it here. 9 to 13, so 9 goes into 13 one time. 1 times 9 is 9. And then subtract, you get 4. So you can write this as negative 1 and 4 ninths. All right, but most students will leave it as negative 13 ninths. All right, so that was number 1. Okay, so let's look at number 2. Now, number 2, we had this linear equation. And notice that this linear equation has fractions in it. The fractions, though, the denominators, though, are um, uh, real numbers. So 9, 2, and 6. In particular, those are integers. In particular, those are whole numbers. All right, so it makes things a lot easier for us. So what I want to do, though, the way I wanted you to do this is to, first of all, we're going to clear those fractions. So I want you to clear the fractions first. That's the way I wanted you to do this. And so to do that, we're going to first of all need to find the least common denominator. So the least common denominator, so the smallest, the smallest denominator, or the smallest factor that 9, 2, and 6 will go into will be, in this case, 18. Okay, so 9 goes into 18 2 times, 2 goes into 18 9 times, 6 goes into 18 3 times. So that's the smallest. If some of you some of you could have used 36. 36 is not the least. 36 is a common denominator. It will still work, but then you'll be dealing with larger coefficients for your variables. You'll get the same answer, but it makes things a little bit more challenging for you. Now, this is not that bad because um, uh, your least common denominator is a numerical value. If these had variables in it, you need to make sure you use the least and not just any common denominator. All right, so there's the least. So now the next thing I needed to do was to show this. So you're going to multiply both sides by that least common denominator. So I need to see, and first of all, you need to recognize that on the left-hand side, you have two rational expressions, two fractions here. So you can put that in brackets. So we're going to say 4x plus 5 divided by 9 minus x plus 6 divided by 2. So put that side in brackets. On the other side, on the right-hand side, I'm going to leave it as it is since that's just one fraction, one rational expression. So we're going to say times 18 times 18. Multiply both sides by 18. What you do to one side, you have to do to the other. I had to see that part. Then you're going to distribute. So you're going to take each of those rational expressions here, you're going to multiply by 18. So you're going to say 18 times 4x plus 5 divided by 9 minus 18 times x plus 6 divided by 2 equals 3x minus 1 divided by 6 times 18. Now what I'm going to do is I'm going to put those numerators, see these numerators here that have more than one term? I'll put that in parentheses. I'm going to put this in parentheses, and I'm going to put this in parentheses. Okay, that's going to be important. Knowing to put those in parentheses is going to be important. Okay? All right, now the next thing you're going to do is reduce. So you're going to, now remember the whole point of multiplying both sides by 18 is to get these, is to clear your fractions, meaning that you want these numbers here, these factors, to be factors of 1. And so notice what happens. 9 into 9 is 1 time, 9 into 9 into 18 is 2. All right, so notice I got a 1 here. 2 into 2 is 1, 2 into 18 is 9. Okay, I have a 1 there. 6 into 6 is 1, 6 and 18 is 3. So that's that process of clearing those fractions here. So you want ones in the denominator. So once you get ones, notice what happens. 4x plus 5 divided by 1 is 4x plus 5. But that's being multiplied by 2. So the next thing you need to do is to write out what you're seeing. So I'm seeing 2 times 4x plus 5. Over here, x plus 6 divided by 1 is x plus 6. But that x plus 6, that expression, that variable expression has to be multiplied by 9. In this case, we're going to say a negative 9. So minus 9 times x plus 6 equal. And on this side, same thing. 3x minus 1 divided by 1 is 3x minus 1. But that variable expression has to be multiplied by 3. So we're going to say 3 times 3x minus 1. Okay. Now at this point, just like you did in the first problem, right? See, first problem, then you're going to use a distributive property again. So we use a distributive property here. We'll do it here as well. So you're going to multiply every term that's inside that first parentheses by 2. We're going to multiply every term inside this parentheses by negative 9. And we're going to multiply every term inside this parentheses by 3. So 2 times 4x is 8x. 2 times 5 is 10. A negative 9 times x is a negative 9x. A negative 9 times 6 is a negative 54. Equal. 3 times 3x is 9x. 3 times a negative 1 is a negative 3. Alright, so now again, all these are linear equations. So at this point, and by the way, notice that you don't have any fractions left. So you cleared your fractions. You don't have any fractions left, so now it makes it a little bit easier for us to deal with. When I combine like terms, 8x and a negative 9x is a negative x, right? 8 and a negative 9 is a negative 1. I mean, you could see this on your calculator. 8 minus 9 equals negative 1. So I get a negative x. A positive 10 and a negative 54 is a negative 44. So negative x minus 44 equal 9x minus 3. All right, now I'm going to, now there are several ways you can do this. You can bring the variables to the right or bring the variables to the left. Does not matter, right? I'm going to go ahead and just bring the variables to the left because that's what some of you did, and you had to be a little bit more careful when you did that, but let me go ahead and show you. So I'm going to go ahead and subtract 9x from both sides. Now be a little bit careful here. A negative, see, this is understood to be a negative 1. A negative 1 x and a negative 9x. So if you look at those coefficients, when you add those, again, use your calculator if you have to. Negative 1 plus a negative, oops, let me go back, plus a negative 9 is a negative 10. Okay? So that's a negative 10. So I get a negative 10x minus 44 equal 9x minus 9x is 0. Those are opposites. So when you add two terms that are opposites of each other, you get 0 as the sum. And then 0 and a negative 3 is a negative 3. All right, and so we're almost done with this. So now I'm going to add 44 to both sides. And so when I add 44 to both sides, notice what you do to one side, you do to the other. A negative 44 and a positive 44 is 0. So I get negative 10x on this side equal a negative 3 and a positive 44 is a positive 41. And at that point, right now, multiplying x by negative 10, the opposite is to divide both sides by negative 10. Negative 10 divided by negative 10 is 1. 1 times x is x. And so I get, and this is reduced, so I get negative 41 tenths. Okay? And that's what most students will write, negative 41 tenths. Now, if you want to write this as a mixed number, you can. So you'd say 10 into 41. So 10 goes into 41 4 times. 4 times 10 is 40. Subtract, you get remainder 1. So you get 4 and 1/10. In this case, it's negative. Negative 4 and 1/10. Okay? But this is the way most students will write it. All right, so that was number 2. Okay, now number 3, you had this equation. Now this equation is not a linear equation because notice you have variable expressions in the denominator. So this is considered a rational equation. All right, now I asked you, I gave you some hints here. I asked you to indicate the least common denominator, so that implies that you're going to use a least common denominator here, right? And then I also asked you to determine the restrictions. Okay, so when finding the least common denominator, you had to first of all make sure that all these denominators are factored. So if you look at this quadratic expression, when I factor this, and we talked about this fact that usually, not always the case, but many times the factors of this quadratic expression will probably be the linear factors that you see elsewhere in the problem. And so if you look at this, I have these two linear factors which I cannot factor any further. So I'm going to see if this quadratic expression can be factored as x plus 8 times x minus 2, right? And so if you look at that, if we go ahead and check that, x plus 8 times x minus 2, and most students will go ahead and use FOIL because that's what they learned, so I'll just go ahead and do that. And so when I multiply these two binomials, I'm going to get x times x is x squared. The outer is negative 2x. The inner terms when multiplied together, a times x is a positive 8x. And the last, a times a negative 2 is a negative 16. When I combine like terms, which are these terms here, a negative 2x and a positive 8x is 6x. So I get x squared plus 6x minus 16, which is what I wanted. All right, so I found the least common denominator. So the least common denominator would be, in this case, remember, the least common denominator must include every factor you see. So I see an x plus 8. It occurs once here. It occurs once here. So I'm going to use it once. Okay, I see an x minus 2 as a factor. It occurs once here. See an x minus 2 to the first. I don't see any here. I see it once here. So I need one factor. And there's your least common denominator. And to find the restrictions, you're basically going to ask yourself, what values of x will make any of these denominators 0? So let's start with this one. So if you look at this one here, remember you can never divide by 0. So if you ask yourself, where is x minus 2 equal to 0, it's very easy to see that x minus 2, that expression is going to be 0 when x equals 2, right? Because if you look at it, 2 minus 2 is 0. So then I know one of my restrictions, that x cannot equal 2. Then if I go to the other one, x plus 8, same idea. X plus 8 is equal to 0 when x equals a negative 8. So there's my other restriction. Now if I go to this denominator, so I look at the factors, x minus 2, I've already taken care of. So this is going to be 0 when x is 2. And this is going to be 0 when x is negative 8. So there's only two restrictions. All right, so I found the least common denominator. I found my restrictions. Now the work you had to do, this is what I was expecting you to write to get all those points, is to do it the same way we did number 2. So we're going to multiply both sides by that least common denominator, and then we're going to distribute. That is what I needed you to do to get all those points. All right, so notice that on the left-hand side, just like with the previous problem, there are two rational expressions. So I'm going to put that in brackets. So I get 3x minus 2 divided by, and remember we talked about the fact that when you have this rational expression, make sure you write it in factored form. So I'm going to write as x plus, when I meant this, I didn't mean rational expression, I meant this quadratic expression here. Quadratic expression, put it in factored form, write it here. X plus 8 times x minus 2 plus 4 divided by x plus 8 equal, and on the side, since there's only one rational expression, I'm going to write it without any brackets or parentheses, and I'm going to say multiply by the least common denominator. So remember in the previous problem, the least common denominator was 18, and notice we didn't have any restrictions, right? Because there's no restrictions because my denominators are never going to be 0. This is always going to be 9, this is always going to be 2, this is always going to be 6, so there are no restrictions. But here I have variable expressions, so I do need to look at my restrictions because depending on what the value of x is, my denominator could be 0. All right, so you're going to multiply both sides by the least common denominator, which is x plus 8 times x minus 2. Same thing here, x plus 8 times x minus 2. All right, now one other thing I got to mention is that for some reason, there's always some students that when writing the LCD will put a comma here. Don't put a comma, because when you put a comma, you're indicating that your LCD is a set of factors, when in fact it is a product of factors. So you got to write as a product. Don't put a comma here. All right. So when you're doing that comma, you're making it a list. So you're saying the LCD can be x plus 8. It can be x minus 2, which is not true. It is x plus 8 times x minus 2. And I keep mentioning that, and some of you still end up putting a comma there, even though time after time I keep telling you don't put a comma. That's incorrect. The least common denominator is a product of factors. So if you put a comma, you're going to lose points. You don't get all your points because mathematically putting a comma here is incorrect. Okay, so now we're going to distribute. And so I get x plus 8 times x minus 2 times 3x minus 2 divided by x plus 8 times x minus 2 plus, and then do the same thing here, x plus 8 times x minus 2 times 3x minus 2 divided by, oops, I didn't mean 3x minus 2, I meant 4, right? So 4 divided by x plus 8, sorry about that. So this times this is this, plus, right here, this times this is this, okay? And then equal, and I have enough room here, so I'm going to go ahead and rewrite this over. So it'll be 6 divided by x minus 2 times the least common denominator. All right, so all I did at this point was go ahead and distribute. Now at this point, remember the whole point of multiplying by the least common denominator, just like in that previous problem, is to get factors of 1s in those denominators. Okay, so therefore you, at this point here, you wouldn't have any fractions to deal with. And so if I'm doing this correctly, that should happen. So x plus 8, these x plus 8s divide out, right? Because remember, this right here, you can think of this as this divided by 1. So x plus 8 divided by x plus 8 is 1. So those two factors divide out. These two factors here divide out as well. All right, it's kind of like, and make sure you put 1s here. So it's kind of like saying this is what I'm indicating. So if you look at this right here, you have x plus 8 times x minus 2 times 3x minus 2 divided by x plus 8 times x minus 2, right? So you put this as 1, so now you have, you're multiplying two rational expressions, and then you just reduce. So these x plus 8s divide out, because remember, x plus 8 divided by x plus 8 is equal to 1, right? So it's kind of like saying 9 divided by 9 is 1. All right? So you're going to say factors of 1s in their place. And the same thing here, x minus 2 divides into x minus 2. So those two factors divide out. All right. So over here, the only factor I see in the denominator is x plus 8, and I can reduce it with this one, x plus 8. Put 1s in there as a factor that's left. And then over here, x minus 2, those divide out. So now what you have left is this. Now remember, this 1 times 1 is 1, right? So just like in the previous problem, when I said 4x plus 5 divided by 1 is 4x plus 5, and then we'll multiply by 2, we're going to do the same thing here. 3x minus 2 divided by 1 is 3x minus 2. But 1 times 1 is 1, right? So 1, let me go ahead and write it like this. I'm going to write it like this. 1 times 3x minus 2. I'm just going to write it for right now. 1 times 1 is 1. 1 times 3x minus 2. Over here, let's talk about this. So 4 divided by 1 is 4. Now remember, multiplication is commutative. The order in which you multiply does not matter. But what I want you to notice here is that you have three factors that you're multiplying together. 1 times x minus 2 times 4. So what I need for you to recognize is that, first of all, I can say 1 times 4 is 4, so I can multiply those two first, and then say 4 times x minus 2. So I'm going to write this as plus 4 times x minus 2. That's what this is. Equal, over here, 6 divided by 1 is 6. Same thing here. I'm multiplying three factors together, 6, x plus 8, and 1. So 6 times 1 is 6, and so 6 is being multiplied by 6 plus 8. X plus 8, sorry. X plus 8. All right, so that's where I'm at. So then we're going to multiply, we're going to distribute, just like we did in previous problems. But remember, 3x minus 2 times 1 is 3x minus 2, right? So that's simple. Over here, I'm going to distribute a positive 4. 4 times x is 4x. 4 times a negative 2 is a negative 8, equal 6 times x is 6x, and then 6 times 8 is 48. Combine like terms, 3x plus 4x is 7x, a negative 2 and a negative 8 is a negative 10. That's a 7 here. Negative 10. Equal, and then 6x plus 48. All right, so now notice when I went from this part to this, notice I no longer have any fractions, so it makes things a lot easier for us to deal with. So I have this linear equation. I'm going to go ahead and subtract 6x from both sides, bring all the variables to one side, constants to the other. And when I do that, I get 7x minus 6x is x, subtract 10, equal, this is 0, and then 0 plus 48 is 48. Adding 10 to both sides, and then combine like terms, this is 0, negative 10 and a positive 10, those are opposites. Whenever you add numbers or terms that are opposites of each other, you get 0. X plus 0 is x, equal, and then 48 plus 10 is 58. Now, before you go on, remember you have to check for extraneous solutions, false solutions. So x equal 58 is a solution to this linear equation, but is it a solution to this rational equation? And that's where those restrictions come in. So notice the only restrictions are 2 and negative 8, and so since this is not uh, uh, 2 or negative 8, just as long as it is correctly, then that's going to be a solution. All right, so that's it. All right, now let's look at number 4. So number 4, I wanted, now always read the directions. The direction says solve this quadratic equation by factoring. So if you use the quadratic formula, you would not have gotten any points because that's not what I was asking you to do. I needed to see if you could solve this quadratic equation by factoring. All right, so always follow directions. And I even told you to not use any other method, and some students still do. So whenever you don't follow directions, you don't get any points. All right, so in factoring, now notice I indicated I want you to solve this by factoring, right? So that first of all implies that this is factorable. So let's go ahead and factor this. Notice the GCF, and it's already in standard form, so I see 0 here, and it's in descending order. But notice the GCF of those three terms that's on the left-hand side is 1. So then I'm going to go ahead and try factoring this as a product of two binomials. Now, make sure you put a 0 here because you're saying this equation and then this has to be equivalent to an equation, right? So you got to have 0. Everything you write has to be mathematically correct. So the first part's easy because 5 is a prime number. So the only possibilities for 5x squared would be 5x and x. All right, now for 6 is not prime, but there's only a few possibilities. 6 times 1, 3 times 2, right? And so let's go ahead and try 3 and 2. Let's try that first. So what's going to work though, just to save time here, what's going to work is that I'm going to need um, 2 here and 3 here. That's what I'm going to need. Now the last sign is positive, so that means that these signs that goes inside these parentheses here have to be the same, and they're going to be this middle sign because I need my outer and inner to add up to be a negative 13. So if I put a negative here and a negative there, and then if I go ahead and check, all right, which is always a good idea, is to check this. Always make sure what you write is correct. So if I check this, it's going to work because look, so I'm going to use the fall method here because I'm multiplying two binomials. 5x times x is 5x squared. The outer 5x times a negative 2 is a negative 10x. The inner, a negative 3 times x is a negative 3x. And the last, a negative 3 times a negative 2 is a positive 6. I'm going to combine like terms. I get 5x, and my like terms are the inner and the outer here. A negative 10 and a negative 3 is a negative 13. So a negative 10x and a negative 3x is a negative 13x plus 6. And notice that is what you wanted. Okay? All right, now the next step here is to use a zero factor property. So I've got to set each of those factors equal to 0. So I'm going to say 5x minus 3 equals 0, x minus 2 equals 0. And remember, the reason why we do that is because if you have a product of factors, then one of those has to be 0. There's the only way you can get a product to be 0. So we're going to set both of them equal to 0. And then notice I went from a quadratic equation to two linear equations. So over here, I'm going to add 3 to both sides, and I get 5x equal 3. And then we're going to divide both sides by 5. And when I reduce, 5 divided by 5 is 1. 1 times x is x, equal 3/5. So that's going to be one of my solutions. Over here, add 2 to both sides, I get x to be 2. So my solutions are 2, and the other solution is 3/5. Okay? All right, now in the Next problem, I wanted you to use the quadratic formula. I even made it easy for you. I gave you the quadratic formula. Normally, though, that the quadratic formula is not given, we do expect students to know the quadratic formula. But on that first test, I gave it to you. And all you had to do was just take these values and substitute into the formula. The mistake some students do is they do not put this in standard form. Remember, you got to put this in standard form first, right? So mistake that students will make is they'll say A is 3, B is -4. But the mistake then is that C they'll say is 2, and C is not 2. C is not 2. You first of all had to put this in standard form. So you need to rewrite this as 3x squared minus 4x minus 2 equals 0. And then let's go ahead and determine A, B, and C. So A is a coefficient of x squared, which is 3. B is a coefficient of x, which is a -4. And C, now you see that C is a -2, not a +2. All right, so we get x equal, and we just substitute all these values here into the quadratic formula. So remember, this says the opposite of b. So b is a -4. The opposite of a -4 is a +4, right? That makes sense. So if you look at this, the opposite of a -4 is a +4. So that's what goes here. Plus or minus the square root of b, which is a -4. Remember, we always talked about the fact you got to put that in parentheses because b squared should never, ever, ever be negative. So make sure you put that in parentheses. If you there's always a possibility if you're not careful, you're going to write this as a -16, and it's not a -16. Okay, it's a +16 because a -4 times a -4 is a +16. B squared is never negative. Minus 4 times A is 3, times C, which is a -2. All of that, and you had to show that extension going from here to here. Okay? All of that is being divided by 2 times A, which is 3. So everything you write has to be mathematically correct. Okay, so now we're going to focus on the radicand, or the discriminant here. And so if I look at -4 squared, -4 squared is 16. So I'm going to say 4 plus or minus the square root of 16. All right, now use your calculator if you have to. So remember, subtraction, you can always change to an addition problem. So if I change this to an addition problem, just to kind of visually show you, then notice I have 16 minus 4 times 3 times a -2, right? So the subtraction I can change to addition. So that becomes 16 plus, but you gotta say whenever you change to addition, you gotta say add the opposite. So the opposite of this +4 would be -4. So I get -4 times 3 times a -2. And so this part here, right here, use your calculator, you're gonna get this. You get -4 times a +3 times a -2 equal a +24. So this becomes 16 plus 24. Okay? All right, so this becomes 16 plus 24. All of that is being divided by 6. All right, all of that is being divided by 6. All right, so now 16 plus 24 is 40. So we get 4 plus or minus the square root of 40 divided by 6. So notice I have to see from that division symbol from here all the way to the end of that radical symbol. Okay, just like this. All right, so now you got to remember the direction says simplify radicals if possible. Even if I did not have those directions, it expected that you're going to simplify factors. Radicals rather. You're going to simplify your radicals. So this I did not have to put that. So keep in mind that even though I did not, I have it here. If I don't, you're still expected to simplify radicals whenever possible. That's mathematically what we expect to do. So on this side here, I'm going to go ahead and talk about simplifying the square root of 40, which we can because there is another perfect square other than 1 that goes into 40. So let's think about that. Remember, 40 is 4 times 10, right? And so 4 is a perfect square. So we're going to rewrite this as the square root of 4 times the square root of 10. And we know that the square root of 4 is 2, so it becomes 2 square root of 10. So the square root of 40, right here, I'm going to write as 2 square root of 10. So it becomes 4 plus or minus 2 square root of 10, all divided by 6. Now the next thing I needed to do was to recognize that this 4, this 2 here, the factor of this, of one of the factors of this term here is 2. So this 4, this 2, and this 6 are all divisible by 2. So I expect you to go further with this. So 4 divided by 2 is 2, plus or minus. 2 divided by 2 is 1, so 1 square root of 10 is square root of 10, divided by, and then 6 divided by 2 is 3. And so that is what I expected you to write. So 2 plus or minus the square root of 10 divided by 3. Now, if you wanted to write it as two separate solutions, you could. So you could say r 2 plus the square root of 10 divided by 3, comma, 2 minus the square root of 10 divided by 3. Okay? All right, so that was number 5. Okay, now number 6. So number 6, you have, and notice the direction says solve this following quadratic equation by using the square root property. Okay, don't use any other method. I even told you right here, do not use any other method. So I need you to use the square root property. So if you went ahead and you squared the binomial 5x minus 7 and ended up with a quadratic equation, and then went ahead and used quadratic formula, you would not have gotten any points because you did not use the square root property. So when using the square root property, remember when using the square root property, first of all, you want to make sure that whatever is being squared is by itself. And it is here. So it's already in that form that you need. So then the next thing you had to do, was then to get rid of this squaring function here. So the opposite of squaring is to square root. So I'm going to take the square root of both sides. But remember, whenever you take the square root of both sides, we got to end up with a plus or minus on that other, on one of the sides. And so the square root function and the square function undo each other. So you get 5x minus 7 equal plus or minus the square root of a negative 18. Now, remember, the square root of a negative 18 is not a real number, but you can go further with this because you learned about imaginary numbers. So you know the fact that the square root of a negative 1 is defined to be the imaginary unit I. So you are expected to go further with this. So if you wrote no real solution, you're not going to get most of your points. Okay? You'll get up to what you have here. But all that other stuff that you did not write, you're not going to get those points. So you have to use the fact that, hey, I know about imaginary numbers, so I need to use it. All right, so the square root of a negative 1 is I, and then let's talk about the square root of 18. So the square root of 18, it can be simplified because the largest perfect square that goes in 18 is 9. So I can write this as square root of 9 times the square root of 2, and the square root of 9 is 3. So I get 3 square root of 2. All right, and so then this right here, then the square root of a negative 18 becomes square root of a negative 1, square root of 18, which is I, and then square root of 18 I just found to be 3 square root of 2. But the way I'm going to write this is I'm going to put the I between the imaginary unit rather between 3 and the radical symbol. So I'm going to write it like this. All right, so this becomes 5x minus 7 plus or minus equals plus or minus 3i, that's an I, square root of 2. All right, and then next we're going to add 7 to both sides. And so because remember I'm trying to get x by itself, so when I add 7 to both sides, I get 5x equal 7 plus or minus 3i square root of 2. And then all I need to do to get the answer now is to divide by 5. So dividing both sides by 5 and reducing, I get x equal, and then notice that there's nothing I can simplify here. So if you look at the previous problem, so I could go further here, right? Because 4, 2, and 6 are all divisible by 2. They're even numbers, and so I get this. Here, though, 7, 3, and 5, other than the factor 1, there's no other factors that 7, 3, and 5 have in common. All right, so then I'm going to leave it like that. So x equals 7 plus or minus 3i square root of 2 divided by 5. And so that's going to go here. 7 plus or minus 3i square root of 2 divided by 5. Okay? All right, so that's number 5, number 6 rather. Number 7, notice I asked you to solve this polynomial equation by factoring. Okay, that should be factoring. And I want you to show the required work. So notice that I already made it simple for you. I already have 0 here, and it's already in descending order. So I have these 4 terms, and so if I'm going to solve this polynomial equation by factoring, then I need to use grouping. So we have to use factor by grouping, right? And so what usually works, not always the case, because you've learned in previous semesters that would need to sometimes reorder the terms. But for us, all you had to do was group the first 2 and then group the last 2. And so when I group the first 2, let me go ahead and rewrite this over to make it look a little bit better. All right, so when I group the first 2, and uh, and I and let's go ahead and cover this part up. So when I group the first 2, notice that the GCF of the first 2 terms is x squared. So I can factor out an x squared. So I get x squared times x minus 2. Now when I group the last 2 right here, the GCF here is a positive 7, but I'm going to factor out that plus, I'm going to write it as plus 7. So plus 7 times, and so 7 times x is 7x, and then a positive 7 times a negative 2 is a negative 14. Don't forget to say equals 0. Now at this point, you have to recognize that these 2 terms here, see these 2 terms right here and right here, so those 2 terms both have a common factor, x minus 2. So you need to factor that out. So I get x minus 2 times, now when I factor out this x minus 2 right here, when I factor that out, you're left with x squared. And when I factor out this x minus 2, you're left with 7. So x squared plus 7 equals 0. You had to show this, okay? Because remember, I wanted you to do this by factoring. So when you got to this point, you still haven't factored. Remember, factoring, writing a polynomial as in terms of factoring is writing it as a product of factors. So this is the product of factors here. Okay? All right, so at this point you have to recognize, hey, I have 2 factors whose product is 0, so one of those has to be 0. So that's where that 0 factor property comes in. So x minus 2 equals 0, x squared plus 7 equals 0. Now notice I went from this cubic, the x cubed, the largest exponent, I went from this cubic equation, this cubic polynomial equation, to a linear equation and a quadratic equation. This linear equation is easy. So x minus 2 is equal to 0 when x equal 2. So there's one of your solutions. Over here, though, this is quadratic. So this quadratic equation has 2 terms on the left side, right? Whereas in the previous problem, if I go here, this quadratic equation had 3 terms. Notice that the 3 terms here, this term contains the second degree, so this we call the second degree term. This is called the first degree, so x to the first degree term, and this is your constant. Over here, what's missing is that first degree term. I have my second degree term and my constant, but not my first degree term. Whenever that's the case, then all you have to do is use, now you got to show that though, but whenever that's the case, all you have to do is use the square root property. So meaning this, get x squared by itself. So when I get x squared by itself, I get x squared equals a negative 7. And now that looks something like this, right? So you have some expression squared equal a number. That's what you have here. So now you can take the square root of both sides, just like this, plus or minus. The square function and the square root function undo each other, so you get x equal. Now you got to remember the square root of a negative 7. Now 7 is a prime number, but the square root of a negative 7, that's that imaginary unit that you have to remember that you know how to do. So that's the square root of a negative 1, square root of 7, so that's I square root of 7. Okay? Or if you want to rewrite it as square root of 7 times I, you can, but make sure that I does not look like it's under that radical symbol. Okay, it's not part of that radicand. If it does, then you cannot get full credit because then it's not mathematically correct. So that's why we tend to, in that case, I usually tend to write the factor I in front of the radical so it doesn't look like it's underneath the radical. So then this becomes plus or minus I squared of 7, and that's it. So those are your three solutions, and there are three of them. Two here, one here. So you can write it as you can write it as x equal 2 comma plus or minus I squared of 7. Or if you want to write it as three separate solutions, you can. 2 I squared of 7 negative I squared of 7. All right, so that's number 7. Okay. All right, now number 8. Number 8. What I need for you to recognize is knows the direction. Direction says solve the following quadratic equation using U substitution. So what you had to recognize was that this quadratic equation here, and this is quadratic because if you were to multiply this out, see you're squaring this, you would get, when you combine all like terms, you get x. Your largest term will be a second degree term. But I need you to recognize that this expression, this equation rather, both contain the expression 3x minus 2. So that's what you're going to want to substitute. So you want to let u equal that 3x minus 2. So once you let u equal, and I'm even giving you a hint, I told you let u equal blank. I needed you to show me that u would have to be 3x minus 2. Now you're going to show the rest of the work. So what I expect you to do is to say, all right, I'm going to substitute I'm going to substitute u for 3x minus 2. So wherever I see 3x minus 2, I'm going to write the variable u. So I get 2u squared plus 5u, 5 times 3x minus 2, that's u, minus 12 equal 0. And now for us, what's going to happen is that this is going to be factorable. All right, so that's going to be factorable. So let's go ahead and factor this. If for some reason you wanted, and some of you did use quadratic formula here, and that's fine. But if you can factor this, factoring is a lot quicker. But you do have to check your work because you could factor incorrectly. Some students went ahead and used quadratic formula, and that's okay. All right, as long as you get the value of u. So we got to solve for u now. So we got to figure out, well, what is u? So let's go ahead and factor this. So when I factor this, 2 is a prime number, so that's going to be easy. 2u and u. Now for 12, and you got to remember, I need to get that outer and the inner. I need to get the outer and inner to add up to be 5u. And so the only thing that is going to work here will be, let's see, I need 12, right? So let me just kind of show you the process you're going to go through. So let's see, let me write it here. So you get 2u squared plus 5u minus 12. All right, so we know that I need 2u and u, right? But I want the last terms to have a product of negative 12. All right, so for 12, there are several possibilities. Remember, let me write it here. For 12, you can say 4 times 3, 6 times 2, 12 times 1, right? So let's go ahead and try 4 and 3 first. All right, so for 4 and 3, for example, let's suppose I put 3 here and 4 here, okay? Now, I want you to notice something. The outer terms, now notice I didn't put any signs here, and that's okay. We're going to do this in a little while. But the outer terms here are 8u. The inner term, the inner terms when I multiply them is 3u. And remember, the last sign's negative right here, so that means that they're going to be different. So since they're going to be different, I'm going to go ahead and subtract those. And when I subtract those, 3u from 8u, I get that 5u. See that? So what that means is that the 3 and the 4 are in the correct spot in terms of these binomials. What I have to do though is determine, remember the last sign's negative, so that means these signs are different. Determine which one's positive, which one's negative. Well, since I want a positive 5u, then that means that the 8, which is larger than the 3, has to be positive, and then that 3 has to be negative. And now notice 8u and a negative 3u is 5u. So that means that if this is going to be a positive 8u, then that means the 4 has to be positive. If this is a negative 3u, that means the 3 has to be negative. All right, so that goes here now. So I get 2u minus 3, and then u plus 4. All right, and just like we did in the past, you have two factors whose product is 0. So one of those has to be 0. So I get 2u minus 3 is 0. U plus 4 is equal to 0. And then adding 3 to both sides, I get 2u equals 3, which means u is 3 halves. Over here, subtract 4 from both sides, I get u equals negative 4. Now remember, that is u. Okay, I want to solve for x, right? My original equation had x in it, so I got to solve for x. So now what you got to do now is go off to the side and show the work. So now you got to figure out what x is. All right, so I know that u is equal to 3 halves. Now we got to solve for x. Solve for x. So I know that u equals 3 halves and that u equals negative 4. All right. But remember, remember u is this. So now we're going to substitute in place of u. I'm going to substitute 3x minus 2. So 3x minus 2 equals 3 halves. 3x minus 2 equals a negative 4. All right, now notice this one has fractions in it. This one does not. So let's go ahead and do this one first. So I'm going to add 2 to both sides here. So I get 3x equal a negative 4 plus 2 is a negative 2. So x equals negative 2/3. I'm going to divide both sides by 3. So there's one of your solutions. So one of my solutions for x is going to be negative 2/3. Over here, the best way to do that one is to think of, just like we did before, let's go ahead and clear the fractions. That's what some of you did, and that's fine. So when I clear the fractions, so let me go ahead and write it over. So when I clear the fractions, that means I'm going to multiply both sides by 2, right? Because my least common denominator is 2. So then I distribute, I get 2 times 3x is 6x, 2 times negative 2 is negative 4, equal, these 2's divide out, that was a point of multiplying both sides by the least common denominator, and now this is easier to solve. So I'm going to add 4 to both sides, and so I get 6x equals 7, and so therefore when I divide both sides by 6, I get x to be 7/6. All right, and so that is the solutions to this equation here. Okay, number 9, you wanted to solve this linear inequality, this compound linear inequality, and notice that this compound inequality here, there are the variable expressions in the middle, and then you have constants on the outside, right? So the best way to do that is to determine what values of x will make this expression less than or equal to 10 and at the same time greater than negative 4. The best way to do that is to get x in the middle, to find get x to be by itself in the middle. So basically the thing you're going to do is if all you had was, let's say, this right here, the simple inequality, that to solve for x you're going to have to add 2 to both sides, right? Same thing here though, but it's 3 parts, so you have to add 2 to all 3 parts. And so when I do that, I get negative 4 plus 2 is a negative 2 is less than 3x, because this is 0, is less than or equal to, and then 10 plus 2 is 12. And then to get x by itself, I'm going to go ahead and divide all parts by 3. And when I divide all parts by 3, I get negative 2/3 is less than x. 3 divided by 3 is 1. Is less than or equal to, and then 12 divided by 3 is 4. And there's your solutions. So the solutions to this original equation, which was this, the solutions to that original compound inequality, rather, I said equation, but I meant inequality. This compound inequality would be any real number that's between negative 2/3 and 4, including 4 because of the equal sign. So when you write this as interval notation, you're going to say parentheses negative 2/3, parentheses because there's no equal sign, negative 2/3 will never be a solution, comma, all the way to 4 with a bracket. All right, so let's kind of figure out, so there's your answer here, but I just want to show you something. So I want to show you why negative 2/3 is not a solution. So when you go back to this original equation, this is what you're going to see. You're going to see negative 4 is less than 3 times negative 2/3 minus 2, and I want to see if that's less than or equal to 10. Well, the 3's divide out. Okay, so here's what you have. You have 1 times a negative 2 is a negative 2, so I have 4, negative 4 here, is less than negative 2 minus 2 is less than or equal to 10. A negative 2 and a negative 2 is a negative 4, so I have negative 4 is less than negative 4 is less than or equal to 10. Now let's check this. It is true, it is definitely true that negative 4 is less than or equal to 10. True? A negative number is always less than a positive number. But here's where my issue is. And here's why negative 2/3 is not a solution. That's why we needed a parentheses here. It's this part here. Negative 4 is not less than negative 4. negative 4 is equal to a negative 4. So that's why we say that negative 2/3 is not a solution. So we use a parenthesis here. 4 is a solution. You can check that. Let's see why 4 is a solution. Let's see why I have a bracket here. Now, obviously, you have a bracket because of the equal sign, but let's check it. So I have negative 4 is less than 3x minus 2 is less than or equal to 10. So wherever we see the variable x, I'm going to substitute 4. So I have negative 4 is less than 3 times 4 minus 2 is equal to 10. So I already saw the variable x, I substituted 4. So 3 times 4 is 12, right? And so I get 12 minus 2. And I want to see if that's going to be equal to less, is going to be less than or equal to 10. Well, 12 minus 2 is 10. So I get negative 4 is less than 10 is less than or equal to 10. All right, now let's check this. Is negative 4 less than 10? The answer is yes. Is 10 less than or equal to 10? The answer is yes, it's equal to. So that's why 4 is a solution. Okay? All right, so that's number 9. Now let's look at number 10. So number 10, you had this radical equation for number 10. You have this radical equation. And I'm even telling you some things that some of you would forget to do. I'm telling you, make sure you show the work when you check for extraneous solutions. All right, so I'm even reminding you to check for extraneous solutions. All right, so notice I have this radical equation and I have the variables on both sides. Now, what I need to do is get rid of this radical symbol, the square root symbol, and it's already by itself. So whenever it's already by itself, this is what you're going to do. So I just rewrote this over. So to get rid of this square root symbol, the opposite of square rooting is squaring. So you're going to say square both sides, just like this. Square both sides. And so now the square and the square root function undo each other. So you get 2x minus 3 is equal to, and then we have to figure out what x minus 2 squared is, right? So x minus 2 times itself. Well, x minus 2 times itself, when you FOIL that out, will be x squared minus 4x plus 4. So that's going to go here. So x squared minus 4x plus 4. Okay, so now you're going to go ahead. Now this is quadratic, so I went from this square root equation to a quadratic equation. And remember, whenever you raise both sides of an inequality to an even power, whenever you raise both sides of an equation to an even power, it is possible that you are introducing extraneous solutions, like false solutions. So that's why you have to check. So when I put this in when I put this in standard form, and I'm gonna go ahead and transpose both sides, I get x squared minus 4x plus 4 equal 2x minus 3. So I just went ahead and transposed both sides. Now I'm going to bring all these terms to the other side. So I get x squared minus 4x plus 4. Then when I bring this 2x over, I get minus 2x, and then plus 3 equal 0. Combine like terms, I get x squared. A negative 4x and a negative 2x is a negative 6x. A positive 4 and a positive 3 is a positive 7 equal 0. Now this is factorable. For us, it will be factorable. And you could use the quadratic form if you want to. But since it's factorable and the coefficient of x squared is 1, it's easier just to factor. So I'm going to get, make sure I think I did something incorrect here. Let me go back and figure what my mistake is. Hold on. All right, so notice I did make a mistake because notice when I got to this point, hey, this is not factorable. So I did make an error. Now let me show you what my error is right here. This is x minus 3, right? What did I put? X minus 2. So be careful. This is x minus 3. So that's going to change this. X minus 3 times x minus 3. So I realized I had an error because this was supposed to be factorable for us, and it was not. So when I multiply x minus 3 times itself, this was my error. I just forgot. I wrote it down wrong. It is possible, so you got to be very careful. So I get x squared. The out and the inner is going to be a minus 6x and then plus 9. All right, so that's going to be a minus 6x and then plus 9. That's a 9 here, okay? Minus 6x plus 9. And so I transpose both sides, so minus 6x plus 9, right? minus 6x right here plus 9. All right, and then everything else should be correct right here. All right, now a negative 6x and a negative 2x is a negative 8x, right? So that's negative 8x. And then 9 plus 3 is 12, right? So it'll be 12 right here. Okay? All right, so now I think it should work. So when I factor x squared minus 8x plus 12, I'm going to get x minus 6 times x minus 2. All right, so I'm going to set each factor equal to 0. So I get x minus 6 equals 0, x minus 2 equals 0. And so when I solve for x, I get x to be 6 and x to be 2. All right, so now we got to check this. All right, we have to check for extraneous solutions. So remember, these are solutions to this quadratic equation right here. But are they solutions to the radical equation, the square root equation? So that's where you got to check. So I'm even telling you to check, right? So let's check x equals 6 first. Okay, so we're going back to the original equation. So here's the original equation. Square root of 2x minus 3 equal x minus 3. So wherever you see the variable x, I'm going to substitute 6. So I get the square root of 2 times 6 minus 3. And I want to see if that's going to equal 6 minus 3. So wherever I saw the variable x, I substituted 6. Well, 2 times 6 is 12, right? 12 minus 3 is 9. So that's going to be the square root of 9. And we know that the square root of 9 is 3. On this side, on the right-hand side, 6 minus 3 is 3, and notice those are equal. So this checks out. So x equals 6 is a solution. Okay? So that's going to be a solution. Let's check x equal 2. And so when I do that, go back to the original equation, the square root of 2x minus 3 equal x minus 3. So wherever we see the variable x, I'm going to substitute 2. So I get the square root of 2 times 2 minus 3. And I want to see if that's going to equal 2 minus 3. Well, 2 times 2 is 4. 4 minus 3 is 1. So I get the square root of 1. And the square root of 1 is 1. Positive 1. Over here, 2 minus 3 is a negative 1. And notice those are not the same. So that means that x equal 2 is an extraneous solution. It's a false solution. Okay? So now let's go ahead, and I even kind of made it easier for you. I'm asking, are there extraneous solutions? The answer is yes. We just know that now, right? 2 is an extraneous solution. If so, what is the extraneous solution? So it's 2. So what is the real solution to the original equation? The real solution to the original equation is 6, right here. Okay? All right. So the solution to the original equation is 6. So that's why you'll see sometimes, now usually this is not asked right here, but I just wanted to make sure that I made you go through the process. So usually though, you'll say the solution is x equal 6 only. All right. 2 is extraneous, so that's a false solution. So it's not a solution to the original equation. All right, so that's number 10. And then finally, number 11. So let's do number 11. So number 11, you have this rational equation again. And notice I am telling you, I need for you to tell me what the LCD is and indicate the restrictions. Okay, so when I do that, I need to factor this quadratic expression here, and it's usually going to be, normally it's the linear factors that you see here. So it'll be x minus 4, x minus 3, and it does check out. So the LCD is x minus 4, x minus 3, right? So your restrictions, x cannot equal. So if you look at x minus 4, what's going to make that denominator 0 is when x is 4. And what's going to make this denominator 0, x minus 3, that expression, is when x is 3. Over here, x minus 4, I've already taken care of it. And then over here, x minus 3, I've already taken care of it. So there's your LCD, and those are restrictions. So now we're going to multiply both sides by the LCD so we can clear the fractions. So that's what I wanted you to do. So this is going to be your work for this. So on this side, you have two rational expressions. We'll put that in parentheses or in brackets. So x divided by x minus 4 minus 2 divided by x minus 3 equal, over here, I get 3x minus 7 divided by, and then make sure you write in factored form. So x minus 4 times x minus 3. And so I'm going to multiply both sides by the LCD, which is x minus 4 times x minus 3 times x minus 4 times x minus 3. Now this point, just like you did in one of the other problems, you're going to go ahead and distribute. So I get x minus 4 times x minus 3 times that first rational expression minus, and then the LCD times that second rational expression. So x minus 4, x minus 3 times 2 divided by x minus 3 equal, and we'll go ahead and rewrite this over, 3x minus 7 divided by x minus 4, x minus 3 times x minus 4, x minus 3. Okay. Now remember, now this point you're going to reduce. So these x minus 4s divide out. You get factors of 1. Make sure you put factors of 1 here. These factors of x minus 3s divide out. And then these factors of x minus 4 and x minus 3 divide out. So you get 1 times x is x. So that x is being multiplied by x minus 3. So x times x minus 3. Okay, and over here I have 2 over 2 divided by 1 is 2. So 2 times 1 is 2. So I'm going to write this as minus 2 times x minus 4. So that's what you have to write this as. So those three factors here multiplied together is this expression. Equal, over here I have 1 times 1 is 1. And then 1 times 3x minus 7 is just 3x minus 7. Okay, that's what I have at this point. So notice I no longer have any fractions. But what I do have, though, is if you remember in that second problem, I had this, no, the second one, the third one. In the third problem, I had this rational expression as well, right? Except when I came to this point, I ended up with a linear equation. Now I have a quadratic equation because x times x is x squared. X times a negative 3 is a negative 3x. So this x squared, now I have quadratic. A negative 2 times x is a negative 2x. A negative 2 times a negative 4 is a positive 8 equal 3x minus 7. So I have this quadratic equation. So I'm going to bring all the terms to one side so I can put it in standard form. So I get x squared minus 3x minus 2x plus 8 minus 3x plus 7 equal 0. So I brought those two terms to the other side. Combining like terms, I get x squared. A negative 3x and a negative 2x is a negative 5x. A negative 5x and a negative 3x is a negative 8x. And then 8 plus 7 is a positive 15 equal 0. And so this is factorable. Or you can use a quadratic formula, but we're going to go ahead and factor this. So when I factor this, I get x minus 5 times x minus 3 equals 0. And so I'm going to set each of those equal to 0. So x minus 5 equals 0 using the zero factor property. Since I have a product of factors equal to 0, one of those has to be 0. And when I do that, I get x to be 5 and x to be 3. All right, now, I want you to notice that 5 and 3 are my proposed solutions. So these are what's called your proposed solutions. So x equal 5 and x equal 3. You have to check and see if any of these proposed solutions are restrictions or extraneous solutions, false solutions. So these proposed solutions are solutions to this quadratic equation, but are they solutions to this rational equation? That's the question. So if I look at this 5 and 3, I want you to notice that one of my restrictions is 3. So that's going to be a false solution. That's going to make this equation not a true statement. So then you're going to say, are any of these extraneous? You're going to say yes. If so, which one? It's the 3. It's the one that x equals 3. And so which of the proposed solutions is the solution to the rational equation? The only one is 5. So this is your solution. This right here is a restriction, right? Which we'll call extraneous solution. So a false solution. So it's a solution to this quadratic, but it's not a solution to the original equation. Okay? All right, so that is it. So that was the key to those 11 problems that you had to deal with.